All right, welcome to Chapter 2, Descriptive Statistics. All right, again, I recommend you read these chapters in the online textbook. It definitely will help you understand the material even better. All right, so Section 2.1, Stem and Leaf Graphs, also known as stem plots. We'll also talk about line graphs and bar graphs. All right, so in this chapter, you will study numerical and graphical ways to describe and display your data. This area of statistics is called descriptive statistics, right? Because graphs and all these things will help us describe statistics to other people to get your point across. You'll learn how to calculate and, even more importantly, how to interpret these measurements and graphs. All right, so here's the first one. Again, it's called a stem and leaf graph. So here's the example. The data are the distances in kilometers from a home to local supermarkets. Create a stem and leaf plot using this data. All right, so what we're going to do with a stem and leaf plot, they're actually pretty easy to do. First thing we're going to do is draw a straight line down. It doesn't have to be perfect. There we go. We draw a straight line down. On the left side here, we'll have the stems. On the right side, we'll have the leaves. Okay. Now look at all the data that we have. We have all this data. And it's a digit with a decimal in the tenths place, right? So what we're going to do is we're going to break that into two pieces here. All right, so the stem is going to be the digits, all right? So look at all the data we have. Look at all the different stems, all the digits in front of or to the left of the decimal point. We have, let's see, 1s, 2s, 3s, 4s, 5s, 6s, but then we have a little gap there up until 12, right? Well, with a stem and leaf plot, you have to represent all the stems, even if there's no leaves that go with them. So we're going to do it like this. We're going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, these are the stems, the numbers to the left of the decimal point. The leaves are going to be the tenths place of all these digits. All right. So there's a few little rules, and we'll go through them as we pick out the data. So for the stems of 1, look at, we have 1.1 and 1.5. So the leaves will be 1 and 5. Okay, because the 1 is to the right of the decimal and the 5 is to the right of the decimal for a stem of 1. So 1 and 5. Now we look at the stems of 2. Let's see, we have 2.3, 2.5, and 2.7. So we'll write 3, 5, and 7. And notice how I'm kind of trying to line these up and space them out somewhat evenly. All right, now for a stem of 3, we have all these values here. So notice that we have multiple 3's in there to the right of the decimal place. So we'll do a 2. We'll put 2 3's in there representing these two guys right here, and a 5, and an 8. All right, and then we go on to the 4's. So we have 0, 2, 2 5's. So 0, 2, 5, 5, and 7. Oh, and 8. There we go. All right, and then we go on to the 5's. There's a 0.5 and a 0.6, so 5 and 6. For the 6 here, we've got a 5 and a 7, but now notice for the stems of 7, 8, 9, 10, and 11, we have no leaves, so we leave it blank. But for 12, we do have a 0.3. Now the nice thing about a stem and leaf plot is, too, we can go backwards. We could actually read this and recreate the data set, okay? Because again, just the way we put it together. This 6 and this 5 represent 6.5 right there, that data point. Okay, so again, with the stem and leaf plot, you can take the raw set of data and create the stem and leaf plot, or you can take the stem and leaf plot and recreate the raw set of data. Okay, all right. Another type of graph we have are called line graphs. So guess what shape we're going to use? Yep, you got it. We're using lines, right? Yeah, they're not that creative when they make these terms. So a line graph, another type of graph that is useful for specific data values, is a line graph. Here's an example. In a survey, 40 mothers were asked how many times per week a teenager must be reminded to do his or her chores. The results are shown in the table and in the figure. So this is a frequency graph, right? We've talked about these, a frequency table. So on the left side here is the number of times the teenager is reminded, anywhere from 0 to 5 times. And the frequency, how many times, how frequent the parent had to ask the child to do their chores. So what you would do is create these XY axes right here, label them with the proper numbers. These are very easy, that's why I'm kind of going fast through them. And the heights here, you notice, are the frequencies that go here. Okay? And as always, make sure you label everything properly. Remember, you're trying to get your data set across to someone who doesn't know what this data is all about. We're trying to share this data with them. All right? All right, so there we go with a line graph. Bar graphs, not very shocking, but bar graphs use bars. Pretty easy. Let's see, so here's an example of a bar graph. By the end of 2011, Facebook had over 146 million users in the US. The table shows 3 age groups, the number of users in each age group, and the percentage of users in each age group. Construct a bar graph using this data. Okay, so we're going to create this bar graph, very similar to the line graph. Of course, you're going to draw your y-axis, your x-axis. We're going to label everything, right? Make sure you get all the categories in there. And these are the age groups, of course, that they gave us on the table. And this is typical. You'll be given a table and be asked to create the different types of graphs from it. Now, the thing with using frequency right here is these numbers are huge. I mean, we could, adjust the scale on the y-axis here to accommodate those, but it may not be so accurate, right? So what we're going to do is we're going to use the relative frequencies, the proportions. Okay, that's why we're labeling the y-axis with proportion. The biggest proportion is 45%, so just have one that goes a little bit higher than that, so that we can make sure all the bars get represented. All right, so the height of each bar represents the percentage, the proportion. Okay, and 36, so we're approximating on some of these, 19%, etc. Okay, so there we go. There is your bar graph. Nice and easy. Oh, and important, of course, need to make sure you leave space between the bar graphs. All right. Let's see, section 2.2 here. Histograms, frequency polygons, and time series graphs. So histograms are the ones, histograms and bar charts, probably the graphs you'll use the most in this class. But the rest are still good to go over. It's good to understand them. Let's see, so a histogram. So there's this big, old fancy mathematical definition here of a histogram. The big picture is a histogram is very similar to a bar chart, except the bars touch each other. That's the difference. Okay. All right, so a histogram consists of contiguous adjoining boxes. The boxes are touching. It has both a horizontal axis and a vertical axis, just like the bar chart. And you label everything appropriately. The graph will have the same shape whether you use frequency or relative frequency. That's kind of cool, and that actually goes with bar graphs as well. Bar graphs and histograms, whether you use frequency or relative frequency on the y-axis, you're still going to get the same shape to the graph. Let's see, the graph will have the same shape with either. Oh yeah, so I said that. So the histogram, like the stem plot, can give you the shape of the data, the center, and the spread of the data. A rule of thumb is to use a histogram when the data set consists of 100 values or more, because we're going to group them. We're going to put them in groups. To construct a histogram, first decide how many bars or intervals, also called classes, represent the data. Many histograms consist of 5 to 15 bars or classes for clarity. The number of bars needs to be chosen. So that's just your job. Tests and quizzes, I'm not going to make you work that hard to create these classes because that can get kind of tricky, but I'm going to show you an example in a minute. It'll at least give you an idea. All right, choose a starting point for the first interval to be less than the smallest data value. A convenient starting point is a lower value carried out to one more decimal place than the value with the most decimal places. Don't worry about that too much. I'm going to show you how to do this right here. Okay, so here's the example. The following data are the heights in inches to the nearest half inch of 100 male semi-professional soccer players. The heights are continuous data since height is measured, right? Remember, anything that we can measure is continuous data. All right, so there's that big old list of heights. So what we're going to do is we're going to draw a histogram here. Okay, so again, a histogram, we're going to have the axes here. This may not come out too perfect. Actually, it looks pretty good. Okay. All right, so what we're going to look at is here, we're going to kind of pick classes. We're going to look at the smallest data point and the largest data point. Now, because, humans are built the way we are with most of us with five fingers on each hand, 5 toes on each foot, etc., we like things in groups of 5s or 10s, right? So this will but it'll work out really well with the data. So we have the lowest value of 60 and a highest value of 74. So what we should do is make our graph go, the vertical axis, the horizontal axis, the bottom, go from 60 to 75, right? That would make sense. So we can say there's 60, and we could go by 5s here, right? So there's 65, 70, and 75. And picking these class widths here is kind of arbitrary. The thinner you make these gaps in here, the more data you'll see, or the more trends in the data you'll see with the heights of the bars. But this should be good enough for now. So what we're going to do is we're going to quickly make a frequency distribution. So we're going to find all the values. So what are these? These are heights and the frequency for each group. So we'll follow the bars at the bottom here. We'll do 60, but we're not going to go up to 65. What we're actually going to do is 64.9, right? Because we just want to be just below 65. Then we'll do 65 to 69.9, and then 70 to 74.9. Okay? So these are groups of, basically 5, or the widths are 5 here, approximately, more like 4.9, but that's okay. So then what we're going to do is we're going to go through this big old list of data, and we're going to count how many values are from 60 to 64.9. So I pre-counted these. Hopefully they work out right. I'm pretty sure they do. But I counted 23 values on this big list up here from 60 to 64.9. 57 values between 65 and 69.9, and 20 from 70 to 74.9, which works out because they told us there's 100 total. All right, so if we add up all these numbers here, 0, yep, we get 100. Okay. All right, so the frequencies, the biggest frequency is 57. So maybe we can make the biggest frequency, and we've got to label this, of course. Let's make sure we label. So these are heights, and this is frequency. Okay, so these frequencies, so we're going to go, we can go up a little bit above 57 so that we capture all the data. So we can make it 60 and maybe in groups of 10. Let's see, 1, 2, 3, 4, 5, 6. There we go. All right, so 10. So label all these, make sure. All right, there we go. So now we'll make the bars the height of the frequency. So for 60 to 64.9, so we'll go up to 65. I'm going to show you how to do this. We're going to do 23, right? So we'll approximate. The bar goes right about there. All right, there we go. There's the first bar. Second bar is going to be a height of 57. So again, remember the bars are touching each other. So 57 is right about there. It's a little crooked, but that's okay. It does not have to be perfect. There we go. And from 70 to 74.9, we have a frequency of 20. So that goes right there. And there we go. So again, notice how the bars touch, and they go up to the lower class of each next category. Okay, so there you go. There's a histogram labeled all properly. Tells you a story of the data. Okay? You can clearly see most of these heights are between 65 and 70 inches. Okay. All right. So now we can do one on our calculator. So remember I said we need those TI-83s and TI-84s pretty quick, and this is it already. You're going to need them already. If you don't have one, you can rent one from the bookstore. You can rent one online. You can buy them online all over the place. You can buy them all over the place. All right? But you need those TI-83 or 84 calculators. All right, so this is what you're going to do. On your calculator, you're going to hit the Stat button. All right, so the Stat button is just to the left of the arrow keys. So hit the Stat button. All right, and then you're going to hit Enter, which is in the bottom right corner of your keypad. Then what you'll see at the top, hopefully at the top of your screen, is L1 and L2. These are your lists. Okay, we're going to use these quite a bit, so by the time this lecture is over, you should be well versed on how to do this. All right, so in L1, we're going to put all the different data values. So these are the data sets. So we have 1s, we have 2s, 3s, 4s, 5s, and 6s, right? So that's what we're going to put in here. So you're going to hit the number 1, then hit Enter. Then number 2, Enter, 3, Enter, 4, Enter, 5, Enter, 6, Enter. All right, so those are our different values. Now in L2, we're going to put the frequency. So L2 is actually, in this case, the frequency. So I already counted these up. There's 11 1s, 10 2s, 16 3s, 6 4s, 5 5s, and 2 6s. Okay, so again, this is what you're going to enter into L1 and L2. Okay. All right. So now what you're going to do is you're going to hit, so I'm going to show you here, hold on. So what we're going to do is on your calculator, you're going to hit the second button, which is the top left corner. It's a different color key. It says 2MD on it. So you're going to hit that second button. Directly above that button is the Y equals button. Okay, so we hit second Y equals, and you'll see at the top it says Stat Plot. All right, and then just hit Enter for number 1. All right, now what we want to do is make sure, because it'll say on and off, right? We want to make sure on is highlighted. If on is not highlighted, use your arrow keys, highlight on, and hit Enter so that on stays highlighted permanently. Okay, then you arrow down to where it says Type, and you'll see a couple different little icons there. First one you see looks like a bunch of dots. Next one looks like that line graph kind of thing. And the next one you'll see, it's going to be an ugly drawing, but it's definitely a bunch of bars touching each other. That's the histogram. The third one in is your histogram. So again, use your arrow keys to go to the histogram icon and hit Enter so that the histogram stays highlighted. All right, next, and then arrow down where it says X list. That should say L1. If it does not, To enter L1, you do this. You hit the second button, top left corner, and then the number 1 key on your keypad. And you'll see a little L1 pop up there. All right, and the next arrow down, it says frequency, or FREQ. We're going to enter L2. Okay, so it's the same way you enter L1. You're going to hit the second button, but now the number 2. All right. Next thing you're going to do, once you have all that entered in the very top right corner of your keypad, you see graph. You're going to hit that button. Now, several things could happen. You could have an error. You could have a weird graph. You could have nothing on your screen. There's all kinds of things that can end up happening here. What we want to see, of course, is a histogram. To make sure that histogram comes up, what you got to do is you're going to hit a few things. If you have any weird lines or anything like that, hit Y equals, just the Y equals button, upper left corner, and clear out any equations you have on that list. Then hit graph again, the graph button. If it doesn't work still, what usually helps is you're going to hit the zoom button, which is in the very top center of your keypad, very top center of your keypad. Hit zoom and then the number 9 button, and you should see the histogram. So I'm going to draw a very rough version of this histogram here, just to kind of show you the shape. So it should look something like this. Okay. Now, if you have weird like gaps in between your bars here, you're going to hit the window button, which is top near the center of your keypad, window button. So hit window, and then go to where it says X scale, XSCL. Make sure that says 1. Okay, if it says anything else, you'll get some weird gaps in these bars. And this is a histogram, so we're not going to want any gaps in the bars. So once you do all that, you should get this histogram, and that's what we were looking to do. Okay, so make sure you know how to do that on your calculator. Practice that a few times. Okay. All right, next thing we have what are called time series graphs. To construct a time series graph, we must look at both pieces of our paired data set. So basically you have data levels versus time. We start with the standard Cartesian coordinate system. That's your XY system from back in algebra. The horizontal axis is used to plot the date or time. So down across the bottom, date or time. Date or time increments, and the vertical axis is used to plot the values of the variable that we're measuring, those frequencies, those distances, whatever it is. By doing this, we make each point in the graph correspond to a date and a measured quantity. So again, just like an XY pair. The points on the graph are typically connected by straight lines in the order in which they occur. All right, so that's what you would do here. So here's your years and your data, and you can plot it just like that. These are not that hard to do. Time series graphs, most of the time what you're going to see those in the stock market, right? When the stocks go up and down over time, that's where you see these in real life. All right, so let's see. Next section here, 2.3, measures of the location of the data. All right, so a few things we have are we have percentile and quartiles. All right, let's see. To calculate quartiles and percentiles, the data must be ordered from smallest to largest. In other words, you'll have a data set, and I'll show you in a minute. You want to make sure you put all those numbers from lowest to highest, left to right. Quartiles divide the ordered data into quarters, quartiles, quarters. Percentiles divide ordered data into hundredths. So percentiles are something you've seen in school before, right? When you take any type of standardized testing, SAT or standardized school testing, they'll tell you your percentile rank, right? So let's say they said your score here, and this is the example here. So if your score is in the 90th percentile, doesn't mean you got a 90% on the test. It means that 90% of the test scores are either equal to or less than your score. That's the definition of a percentile, and that's important. The percent they give you, in this case 90%, if your test is in the 90th percentile, you scored equal to or better than 90% of the people who took that test. Which means, of course, on the opposite end, that 10% of the people scored greater than you. To calculate quartiles and percentiles, the data must be ordered from smallest to largest. We said that. Quartiles divide the... I copied that twice. Well, never mind. There we go. All right, so here's an example. And here's the the equation to find percentile. Okay? So K, the letter K here, is the percentile that they're asking about. So 70th percentile, we're going to put a 70 in for K. And lowercase n, this is important, this is sample size. That's a big one. That's an important variable. We're going to be using it for the rest of this semester. Sample size is little n. Okay, so let's look at the example up here. So listed are 29 ages for Academy Award-winning Best Actors in order from smallest to largest. All right, so there you go. They already just said 29 is our sample size. And they want us to find the 70th percentile. In other words, we're finding which of all these data points is greater than or equal to 70% of all the data points in this group. Okay? So then K equals 70. So we're going to do this. So I equals 70. So now we're just plugging in. And 29 plus 1. All right? So remember your PEMDAS, right? Remember order of operations from back in your algebra classes? Those still apply. So PEMDAS, parentheses first. So we'll do the 29 plus 1, which is 30. Then multiplication, then division, right? So on top, 70 times 30 is 2100, right? All right. And divided by 100. So if we divide that, we get 21, right? Okay. So what they're saying is we want the 21st data point on this list. So what you're going to do is we're going to count, starting at the beginning, number 1, number 2, number 3, etc. And we're going to count up to 21. The 21st data point in this case, so the 70th percentile is 64. Okay? So this I, this value we're finding is the ith, as they call it, but that number of data points. So we're going to count 21 data points, we get 64. 64 is the 70th percentile. Now, we're not always going to get a nice whole number telling us which data point is the whatever percentile we're looking for. All right, so what about the 83rd percentile? Let's calculate that one. So sample size is still 29, but now K, the percentile, is 83. So I is going to be 83 over 100, 29 plus 1. So again, PEMDAS, do the parentheses first. So it'll be 83 times 30 over 100. Now that's a little bit of a pain. So you could punch that into a calculator, which is going to give us 24.9. Now, 24.9 obviously is not a whole number, okay? So we're not going to go to the 24th. There's no 24.9th data point on this list up here. So what we're going to do, though, is we're going to go to the 24th. All right, so the 24th is 71. So 71 is the 24th data point. And then we go up one more to the 25th data point. And what we're going to do is we're going to average these two data points out. Okay? So in other words, we're going to do 71 plus 72 over 2, which is 71.5 years. And there we go. So even though it's not actually a value on the data set, 71.5 years is the 83rd percentile, because that value is going to be greater than or equal to 83% of all of these data points. Okay? All right, let's keep going here. Another example. For the following 13 real estate prices, calculate the IQR. I'm going to show you what that is in just a second, and determine if any prices are potential outliers. These prices are in dollars. Okay, so we got a few things to do. So the the IQR means interquartile range. So the range, the distance between the quartiles. All right, so your quartiles, we have Q1, which is the first quartile, Q2, which is actually, it's the second quartile, but it's more commonly known as the median, the physical center of your data set, and Q3, the third quartile. Okay. The first quartile, because again, these quartiles separate your data set into quarters, right? So you think about it, if you take a piece of wood and you cut it 3 times, you have 4 pieces, right? So there's 3 quartiles that separates the data into 4 quarters. So the first quartile is also the 25th percentile. Oops. Means the same thing. So of course the third quartile would be the 75th percentile. Okay, so that's what we're going to calculate. We're going to find the 25th percentile. So we could do that. We could use the equation we used up at the top. But since we know this is also the first quartile, we can use the quartile equation. So the quartile equation in this one, K equals the number of quartile. Right, so this is the first quartile, so in this case K will be 1. N, little n, is still sample size. So they told us there's 13 real estate prices, so our sample size is 13. So we're going to find this Q1, this 25th percentile, use the equation up there. So I equals, again, since it's the first quartile, we're doing 1 out of 4, and 13 plus 1, because that's our sample size. So again, PEMDAS, parentheses first. So we get 14 over 4, which is 3.5. But again, we got a decimal, right? So when we find these percentiles or quartiles, if we don't get a whole number, we find the lower and the bigger one, right? So in this case, we're going to look for the third data point in a row, all right? And these are not in order, but remember, to find these, we have to put them in order first. So I don't want to write all those down. You'd have to put those in numerical order from left to right. Once you put them in numerical order from left to right, we're going to find the third data point, and then we'll find the fourth data point. So the third data point would be 230,500 plus the fourth data point would be 387,000, and we're going to average these out. So if we do that, we get 308,750. So that's our first quartile. We're going to repeat this process for the third quartile. So Q3, which is really the 75th percentile. Okay, same formula up above. I equals third quartile, so it's 3/4. Sample size is 13. All right, so if we do the math here, if we plug all this into a calculator, we get 10.5. So again, what we're going to do is, since we got a decimal here, not a whole number, we got a decimal. So we got to go to the list that's in order, not the list that's up here, but the list that's in order. And we're going to find the 10th and the 11th data point. So the 10th is 639,000. The 11th is 659,000. And we average those out. And we get $649,000. Okay. All right. So now we got to go back and we got to find this IQR. That's what they asked us to do here. Okay. So what we're going to do is find the IQR and a couple of things with that IQR. So I'll show you in just a minute. So actually I'm going to move this up a little bit. So IQR is, Q3 minus Q1. That's an important equation. So we found the third and the first quartile. So we just simply subtract those two numbers. So this is 649,000 minus 308,750, which is, where is it? There is 340,250. Okay, so there we go. We found the interquartile range. So there's one of our answers. Now, another part of this question said, determine if there's any outliers. So these are the equations for outliers. Sorry, we're running out of room. All right, we're going to find what's called the upper fence and the lower fence. All right, so these are little equations. So the upper fence, we take the third quartile plus 1.5 times the IQR that we just found. Okay, so the lower fence is Q1 minus, that's important, 1.5 times the IQR. And I'm running out of room, but you can see what we're going to do is just plug in. Okay, we have the third quartile and we have the interquartile range we just found. Plug in, follow your PEMDAS, right? So Q3 plus 1.5 times the IQR. And we've got to plug that into our calculator. Let's see, so Q3 is 649,000 plus 1.5 times the IQR, which is 340, 250, and we see it's 100, or let's see, we see it's 1,159,375. That's our upper fence. I'm going to explain what upper and lower fence are in just a minute. Now we calculate our lower fence. So we take Q1, which is 308, 750. We found that before. Minus this time 1.5 times that same IQR of 340, 250. And you'll see we get a negative number, and that's okay. I'm going to explain it in there in just a minute here. Negative 625. Okay, so these are fences, upper fence and lower fence. Think about it in the real world, fences keep things out, all right? So any numbers outside of these numbers, in other words, bigger than the upper fence. So if we have a data point in our set that's bigger than the upper fence or lower than the lower fence, any of those numbers are called outliers, okay? But we look, we don't have any numbers bigger than 1,159,000, right? Okay, so we have no outliers on the higher end, nothing above the upper fence. And the lower fence is a negative number, which obviously you're not going to have a negative valued house. So we definitely have no data points that are lower than the lower fence. So in this case, there are no outliers. Okay, again, think of these fences, upper fence and lower fence. Fences keep things out. Any values to the left or lower than the lower fence, or any values to the right or greater than the upper fence, those numbers from your data set up here would be outliers. But in this case, we don't have any. Okay, there we go. All right, let's see. So interpreting percentiles, quartiles, and the median. So the median is the 50th percentile or the second quartile, right? I told you that before. Think of the word median. The median is that thing in the middle of the road, right? In the physical center of the road. So median means physical center of your data set. Percentile may or may not correspond to a value judgment about whether it is good or bad. The interpretation of whether a certain percentile is good or bad depends on the context of the situation to which the data applies. In some situations, a low percentile would be good. In other contexts, a high percentile might be good. In many situations, there is no value judgment that applies. Again, it's just based on the context of the data. All right, here's an example. At a community college, it was found that the 30th percentile of credit units that students are enrolled for is 7 units. Interpret the 30th percentile in the context of this situation. So what this means is, there's a couple different interpretations that we have here. First one here, 30% of students are enrolled in 7 or fewer credits, right? Credit units. What this also, because that's the definition of percentile. In this case, 30th percentile means 30% of the students are either equal to or below 7 units. Another interpretation here, we could say, just go in the other direction, that 70% of students are enrolled in 7 or more credits. In this example, there's no good or bad value judgment associated with a higher or lower percentile. Students attend community college for varied reasons and needs, and their course load varies according to their needs, right? So it doesn't matter, although, the more you take, I don't know, some of you may think that's not good. It's a lot more stress and all that, but, you also get done faster, so that would be good. Again, it's just up to context. Okay, on to section 2.4 here. All right, section 2.4 is box plots. So these aren't that bad, okay? A lot of typing into your calculator, but that's about the worst part of it. Okay, so this is what you're going to do. Let's see, the following data are the heights of 40 students in a statistics class. Find what's called the 5-number summary, and then use that 5-number summary to create a box plot. So that's what we're going to do. So your job is to take all these numbers in the order they gave them to you here, and we're going to enter those into L1 on your calculator. So reminder, to find L1, you hit the stat button, then hit enter. Now what you're going to want to do is clear L1. So right here, I'm going to write the directions to clear a list on your calculator. Okay, so you're going to use the arrow keys. So you're going to arrow up so that L1 gets highlighted on this screen. Then you're going to hit the clear button, which is below the arrow keys. Then you're going to hit the down arrow key, and everything in L1 should disappear. Okay, so that's an important process to make sure you remember how to clear a list on your calculator. All right, so you may want to pause this video, because what you're going to do is you're going to type in all of these numbers in the order you see them right here into L1. Okay, so do that. Again, like I said, you might want to pause this to do that. All right, so when you come back, this is what you're going to do. All right, so when you come back, you have L1 already set, all these numbers in L1 typed in. So you're going to hit the stat button. you're going to arrow over to calc on your screen. So arrow over to calc on your screen. And what you're going to see is the option number 1 is called 1 var stat. Okay, and you're going to select that option. Either hit number 1 or arrow key to number 1 and hit enter, either way. And right away you're going to see a bunch of stuff come up. You're going to see X bar, which is our sample mean, and all kinds of other data. So what you're going to do is you're going to arrow down numerous times until you get to the bottom of that list of data values. And you're going to see that 5-number summary. And this is what you're going to see. You're going to see minimum, Q1, median, Q3, and maximum. Okay, so minimum means the smallest data value. Maximum, the largest data value. We talked about Q1 and Q3. Those are your quartiles, first and third quartile. And the median is the very physical center of your data set. All right, so you're going to copy those down from your calculator. So the smallest data point is 59. Q1 was 64.5. The median is 66. Third quartile is 70. And our maximum is 77. All right. Now, with if you were going to draw a box plot on paper, then I'm not too worried about the scale. I think you have to do them on the homework program. If you do, the program will have a little feature to build these box plots. So those will need to be to scale. But if you're going to do it on paper, this is what I want you to draw. Draw a box. Right? It doesn't have to be perfect. Put a line somewhere in there. It doesn't have to be in the middle. It can be in the middle if you want. I don't care. And then we're going to draw 2 lines going out like that. Those are called whiskers. Now this is how we label a box plot. All right, so the minimum goes there. Maximum goes there. Q3 is the right edge of the box. Q1 is the left edge of the box. And of course the median is the bar that's inside the box. Okay, so make sure you label those and then label the numbers that go directly below. All right, so the minimum was 59. Q1 is 64.5. Median 66. Q3 is 70. And the maximum is 77. And there you go. You have created a box plot. Lots of fun, right? Okay, awesome. So there's your box plot. Get used to drawing these using the procedure I just laid out here. Okay, next section here, 2.5, measures of center of data. All right, so measures of center, we've talked about a couple of these already, but that's okay. Talk about them again, it doesn't hurt. So the mean and the median. So the center of a data set is always a way of describing location, like how your data is set up, right? The 2 most widely used measures of center of the data are the mean, which is an average, and the median. All right, so mean and median. So we talked about median is that physical center. So we're going to talk about this. So here, definition of mean is just simply an average. That's the easiest definition of a mean. It's an average. Okay? The formula is, and this is the little weird formula. So actually there's some variables I want you to know. So the first one is this Greek letter mu. Right? So we pronounce that mu. It's not an M, it's a mu. And this means population mean. Okay? Population average. Okay? Then we have this other symbol here, X bar, which means sample mean. Okay? Those you need to know, those are important. So mu is your population mean, the mean of the population of data. X bar, it's a little x with a bar over it, is a sample mean. All right, now the formula for either one of these is the same. So mu and x bar have the same formula. we use this little funny looking E that's called sigma notation, and we'll say it's, and I'm going to explain it in a minute. So it's I equals 1 to n of all the x values, x sub I values, over the sample size n. All right? All this fancy stuff right here means is we know what an average is, right? We add everything up and divide by how many you have. That's all that fancy math is right there. Okay, so again, all that symbol means just simply add up all your data points, then divide by the sample size. Okay, so let's try an easy one out here. Example, find the mean. So use this data set. So I know this is kind of the long way, but so this is, it doesn't matter if we use mu or x bar in this case, because it doesn't say whether it's a population or actually it does, I'm sorry. It does say sample. So we're going to use x bar. So we add all these up. 1 plus 1 plus 1. And we keep adding all the data points up. Did I do the right number of 4? No, one more 4. There we go. And we count. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 11 total data points there. So what you'll see, this ends up coming out to 30 over 11, which, if you punch that into a calculator, is 2.7. Now, that's the long, tedious way to do the mean. Of course, what you could do is type all these. We did this a little bit ago, right? Type all those numbers into L1, clear L1. Type all those numbers into L1 and do stat calc option number 1 var stats, and it will give you the mean. Okay. It'll also give you the median, as we found before with the box plots. All right, next term here, median. So median, again, is the physical center of your data. The important thing is here, the data must be in order, right? From lowest to smallest, left to right. Once that's in order, then you can find the physical center. So got a couple examples here. We're going to find the physical center of these data sets. So this first one, notice, so it's the same set we used before, and we said there are 11 data points here. That's an odd number, right? So when you have an odd number of data points, so there's 11 data points here, all you do is you find the number in the physical center. Okay, so which in this case is going to be 3, because think about that. Look, we have 5 values to the left, 5 values to the right. So there it is. The median of this data set is 3. Again, you can also punch those numbers into L1 and do the 1 var stat option. It will give you the median. Okay. All right, so we have another example here. Find the median again, but this time notice we have an even number of data points. So there is no single data value in the middle. There's nothing in the middle. There's a gap, right? So similar to what we did before with the percentiles, when you have an even number of data points and they want you to find the median, the physical center, you find the 2 numbers in the physical center and you average them out. Okay? So the median in this case is 1 plus 2 divided by 2. In other words, just halfway between 1 and 2, which is 1.5. So in this case, the median of this data set is 1.5, even though we don't see the value 1.5 in the actual data set. But this is the process. Okay? All right, next example B here. Similar to the first one we did for median, this one has 7 data points. That's an odd number. So we just find the one right in the middle. So notice there's 3 data points to the left, 3 data points to the right. There's your median. Nice and easy, right? Okay, moving on. All right, so here's another example. So this time, so out of this big old data set, they want us to find the mean and the median using our calculator. So again, the mean is the average and the median is the physical center. So again, first step for physical center for the median, you need to make sure all these data points are in order from left to right, which in this one I was nice and I made sure they were in order. Okay, it makes it a lot easier. But again, we're going to type this into our calculator, all right, using our calculator. So again, you're going to put all these values into L1 using the procedure we talked about before. Make sure, so hit Stat, Enter. That gets your lists. Clear L1, highlight L1 with the arrow key. Hit the Clear button right below the arrow keys. Then hit the down arrow and everything in L1 should disappear. So you're going to probably want to pause this video and type all these numbers into L1. Make sure you get them all in there. Check twice. Make life simple on yourself. Okay, so now that you've got all those typed in, you hit Stat, arrow over to Calc, use the 1var stats option, and you'll see. Right? Let's see. So on your calculator, you'll see the mean is X bar, which should be 23.79 if you typed all those numbers incorrectly. If not, go back to your list L1, see if you typed all those numbers incorrectly. Now scroll all the way down, use the down arrow key on your keypad, scroll all the way down and find median, and your median should be 24. Again, if you don't get the numbers I got, check L1, make sure you typed everything in correctly. All right, some more definitions here. We do have something called the mode as well. Okay, so the mode is the data point, or sometimes data points, that repeat most often on your data set. Okay, so sometimes you could have no mode, right? If you have one of every single data point, right? No repeats or anything like that. This one right here, oh no, that has 2 4s, but anyway, if you have no repeats, then you would have no mode. If you have, so in this case, let's see, look at this data set. 72 is repeated most often, right? So the mode is 72. In this case, it only has one mode. But if you have a tie for the most repeated data points, so let's see, 1, 2, 3, 4, there's 5 72s here. Let's just pretend for a minute there were 5 84s. So 5 72s and 5 84s, that's a tie for the most repeated values on this list. Then the mode would be 72 and 84. Okay, so you could have no mode, you could have one mode, you could have multiple modes. Okay, again, it's just the value or values repeated the most often. All right, so there's no second place in this one. It's most often or it's not. Okay, so in this case, 72 is our mode because 72 is repeated most often in this data set. All right, next thing we're going to talk about is skewness and the mean, median, and mode. So skewness just means, well, you've heard that word, skewed. If something is skewed, it's kind of off, right? So that's what this is, skewness. So if we notice this graph here, this first one, if we draw a smooth curve over the bars, kind of close there, what we notice is we have a peak up top here, but then we have this tail of data trailing off to the left, right? So this would be called a skewed left distribution. Okay. All right, now let's look at the middle graph here. Again, if we draw that smooth curve, what we notice again is a bump in the data here, but then we have this tail that goes off to the right. So this one, of course, would be skewed right. Okay, those are important to know. You're going to see these a lot through this semester. The last one here, this graph here, if we draw a smooth curve, what we notice is it's symmetric, right? So if you remember the word symmetric from your older math classes, symmetric means, if you put a line through the middle, you have mirror image on either side. Okay? So there we go. 3 different types of distributions. We have skewed left distributions, skewed right distributions, and symmetric distributions. Okay, those are important to understand. Okay. All right, now on to 2.7. We have some. We need to talk. So we talked about how to look at the center of data with means and medians and modes. Now we're going to talk about how to talk about the spread of data. How are these data points spread out? So we're going to use standard deviation and variance. So mostly we're going to actually use standard deviation. We're not going to really use variance, but I'll show you anyway. So standard deviation. So your concentration should be on what the deviation tells us about the data. So here's an example to help us understand what the standard deviation is and what it tells us about the data set. So what it is, the standard deviation is how the data is spread out. That's what a standard deviation is. That's important. Write that down. Standard deviation is how the data is spread out. Okay? So let's calculate standard deviation. So you're going to find, again, on your calculator, you're going to put all these numbers into L1 using the processes we've done several times now before. So plug all those numbers into L1. Make sure you clear that list first. And then you go to the Stat button, arrow over to Calc, Option 1, 1 var stats. Okay? So plug that in. Now what you're going to find is there's some different variables. If we go down a little bit here, you're going to find a small s sub x in most of the books or in the homework too. It's just going to be a lowercase s. Either way, it's the same thing. And that's our sample standard deviation. Okay. You'll also see this little symbol, sigma x, or in the homework just sigma, and that's our population standard deviation. Okay. So on your calculator, so make sure you read when you do the homework problems, test problems, quiz problems, read what it's asking for. I didn't do it in this problem, but it will do that on the homework program. It's going to ask you to find either the sample standard deviation, in which case you'll go to your calculator and find s sub x, or it'll ask you to find the population standard deviation, which in that case you would use sigma sub x. They're both on the calculator. Okay, so in this case, on your calculator, s sub x should be 3.14 if you round correctly. Okay? Okay. A little bit more about standard deviation. So a data value that is 2 standard deviations from the average is just on the borderline for what many statisticians would consider to be far from average. Considering data to be far from the mean, if it is more than 2 standard deviations away, is more of an approximate rule of thumb. So it's not always an exact rule, but it just kind of gives us an idea. In general, the shape of the distribution of the data affects how much of the data is further away than 2 standard deviations. Okay, so another example here. Again, go through the process, and we practice a lot so we get used to it. You're going to put all these numbers into L1. Make sure you clear L1 and then type all those numbers in. Type them in carefully. There's a lot of messy numbers there. Once you have that typed in, you again go to Stat, arrow over to Calc, Option 1 var stats. Okay? That's going to give you everything you need to know. So they want us to find all these different things right here. So the sample mean is x bar. So look on your calculator, should be 73.5. Sample standard deviation, again, read carefully, that's s sub x, which should be 17.92. The median, so again, you're going to have to scroll down that screen on your calculator. It'll say MED, and that's 73. The first quartile is Q1 on your screen, which is 61. Third quartile is Q3, which is 90. And remember the equation for interquartile range, the IQR. Q3 minus Q1, so that'd be 90 minus 61, which is 29. Okay. And there we go. So that's a typical test or quiz type question. I'll give you a data set, ask you to find a bunch of different things like this. Okay, and you'll use your calculator to find them. Be a lot easier. Okay, one last concept for this chapter here. Comparing values from different data sets. So we're going to use something called a z-score. If the data sets have different means and standard deviations, then comparing data values can be misleading. In other words, you've heard that old phrase, you can't compare apples and oranges because they're two different things. It doesn't make sense to compare them. But what if there was a way to convert the apples to pineapples and the oranges to pineapples? If we can convert them to the same mean and standard deviation, the same fruit in this case of pineapples, then we can compare pineapples to pineapples. And that's what this thing called a z-score does for us. Okay, so let's look at these equations real quick here. So there's a z-score for sample data and for population data. But by now, like I told you, you got to make sure you know all these little variables. You got to know what these things mean. So important. Know those variables by sight. So quick recap, this is your data point. And I'll show you what that means in a minute. This is x bar, so that's sample mean. Lowercase s, sample standard deviation. The one on the right here is for a population. So this is still the data point. This means population mean, that's mu, and sigma means population standard deviation. Make sure you know those. Make sure you know these equations. Make sure you know what each variable means. Just going to make life so much easier when you do these calculations. All right, so again, z-score. So converting data points to these z-scores, again, we're taking apples and oranges, converting the apples and oranges to pineapples, so that now we can compare the pineapples to the pineapples. Okay, that's what we're going to do. So this is a typical homework test quiz question here, or type of question. So here we go. Two students, John and Ali, from different high schools, wanted to find out who had the highest GPA when compared to their own schools. Not compared to each other, but compared to their own schools. Because to each other, that's easy enough. Well, 2.85 is bigger than 2.75. Obviously, John did better. But it depends on the school and the level of difficulty and all that. So we're going to convert these GPAs to z-scores and then compare the z-scores. Okay? So here, let's do the z-score for John. All right, we use the formula data point minus mean divided by standard deviation. Okay, and all the data is right there that we need. So the data point in question, is 2.85, John's GPA, minus the school mean, which is 3.0, and we're going to divide by the school standard deviation of 0.7. Now, this is important, very important when you make this calculation. Students mess this up all the time. You have a numerator with addition, or in this case, subtraction. You need to put, if you're going to type it directly into your calculator, put parentheses around the numerator, like I just did in the green here. Okay? Or just do that calculation first, do the numerator first, hit enter on your calculator, then divide by 0.7. Either way, be careful, but if you plug this into your calculator properly, you should get negative 0.21. Okay? So z-score of negative 0.21 means, so a negative z-score means we're below average, right? Which makes sense. A 2.85 is below the school average of 3.0. So a negative z-score means below average. A positive z-score means above average. Okay, so John's GPA of 2.85 for his school is basically slightly below, 0.21 standard deviations below average. Now let's calculate Ali's z-score. Same thing, data point minus mean, divide by standard deviation for his school, right? So his GPA is 2.75. His school's average is 2.7. with a standard deviation of 0.3. Again, be careful, put parentheses around that numerator, very, very important. Plug that into your calculator, you should get positive 0.17, which means Ali is slightly above 0.17 standard deviations above the average for his school. Okay, so the question is, which student had the highest GPA when compared to his own school? All right, all you do is you find the bigger z-score, right? Because negative numbers are smaller than positive numbers. So in this case, Ali had the better GPA compared to his school, since he has the bigger z-score. Okay, that's the reason. Bigger b-score, a bigger z-score. Positive 0.17 is a bigger number than negative 0.21. Okay, all right, and there we go. So that's the end of chapter